Properties of waves. When waves travel in a uniform medium, they travel in a straight line. Such waves can be reflected, refracted, diffracted, and can undergo interference. A. Rectilinear propagation. The light wave travels in straight line. It means that the waves travel in straight lines. B. Reflection. Reflection is the bouncing off a wave from a barrier. In B, the direction of the wave changes on reflection, but the speed of the wave, frequency, and wavelength don't change. C. Refraction. Refraction is the change in the velocity of a wave as it passes from one medium to another. Note, refraction changes the speed, direction, and wavelength, but not the frequency of a wave. In B, that there is change in the direction of a wave when it is incident normally at a boundary, from deep water to shallow water. D. Diffraction. Diffraction is the spreading out of a wave when it goes round an obstacle or through a small opening. Note that when diffraction occurs, there is a change in direction but not in velocity, frequency, or wavelength. E. Interference. Interference is the interaction of two or more waves of the same frequency emitted from a coherent source. When two or more waves simultaneously and independently travel through the same medium at the same time, their effects are superpositioned. The result of the superposition is called interference. There are two types of interference. 1. Constructive interference. 2. Destructive interference. 1. Constructive interference occurs when the wave amplitudes are in phase and thus reinforce each other. This results in a wave of even greater amplitude. 2. Destructive interference occurs when the wave amplitudes are out of phase and oppose each other. This results in waves of reduced amplitude. A. Gamma rays have the shortest wavelengths and transfer the most energy of all the waves in the electromagnetic spectrum. Note, the gamma ray is generated in nuclear reactions. B. X-rays pass through soft tissue in the body but will be absorbed by bones. Note, X-rays are high-frequency waves that have great penetrating power and are used extensively in medical and manufacturing applications. Comparing gamma rays and X-rays. Gamma rays and X-rays have very similar ranges of wavelength and frequencies, and so have very similar effects. Their high frequencies mean they carry the most energy and are the most penetrating forms of electromagnetic radiation, so they can be most dangerous to human body tissue when the radiation is absorbed. Both are highly ionizing radiations. The key difference between gamma rays and X-rays is how they are produced. Gamma rays are emitted from the nucleus of an unstable atom during radioactive decay. This is a random process. X-ray generated by an X-ray machine when high-speed electrons collide with metals and lose energy. A. Radio waves and microwave communication. A system using electromagnetic waves to communicate must contain a transmitter to send a signal and a receiver to receive it. Terrestrial radio and TV signals are sent by radio waves. The radio waves travel through the air at the speed of light. The path between transmitter and receiver usually has to be a straight line with no large obstructions, such as hills and tall buildings. So the transmitters are placed on towers that may be hundreds of meters tall. Using a microwave for communication. Microwaves are used to transmit mobile phone signals. Microwave transmitters or base stations are placed on the masts of high buildings to provide better line-of-sight communication over long distances. Although most microwave signals are sent directly, some are sent from a transmitter to a receiver via a satellite. Microwave satellite communications are used for satellite phones and for satellite TV. Note, microwaves range in length from approximately 30 centimeters to about 1 millimeter. Dangers of electromagnetic radiation. When electromagnetic radiations enter living tissue, it is often harmless, but sometimes it creates havoc, harm. The effects of each type of radiation are based on how much energy the wave transfers. The higher the frequency of the radiation, the more energy it transfers, and so the more dangerous it is. For example, radio waves don't carry much energy. There is a low chance they will cause cell damage if they are absorbed, whereas high-frequency waves like gamma rays transfer lots of energy, meaning they are much more dangerous. A. Heating and burns. Some wavelengths of microwaves are absorbed by water molecules to heat up. Cells in the body contain lots of water, so being exposed to microwaves, e.g. from mobiles and wireless internet, can cause cells to heat up. There is a debate about if this is harmful. Infrared radiation is mostly reflected by your skin, but some is absorbed, causing heating. This can lead to burns if your skin gets too hot. B. Skin cancer and eye conditions. Ultraviolet is also absorbed by skin. It is a type of ionizing radiation, and when absorbed it can cause damage to cells on the surface of your skin, which could lead to skin cancer. It can also damage cells in your eyes and cause a variety of eye conditions or even blindness. C. Cancer and radiation sickness. X-rays and gamma rays are also ionizing, so they can cause mutations and damage cells too, which can lead to cancer. But they have even higher frequencies, so they transfer even more energy, causing more damage. This means that sometimes they kill cells entirely, which can lead to radiation sickness, which causes vomiting and hair loss.